The ground is supposed to be static, solid, and predictable. What if the ground were dynamic, flexible, and unpredictable? Initial design of a morphing ground explored the idea of a seating area and an interactive playground for children. The model generated for this concept explored the capability of such a surface and gave much insight into the system's potential design and meaning. This model illustrated that the morphing ground needed to be put into context. The actuation points needed to be evenly spaced across the area so that a full range of motion could be achieved, and that a safety net would need to be run under the surface of the ground to fill the gaps that the actuation created. While walking down Broadway, John and Susan find it odd that the green space in front of the Armed Forces recruiting station in Times Square appears to be moving. Not believing their eyes, they look closer, and indeed the landscape is ever so slightly moving up and down. As they approach, they notice that there are children playing on the green space, and they notice the surface responding to the different people. John and Susan find these interactions odd, so they begin to interact with the landform. John proceeds to stand on the east side and Susan on the west, and they notice that the landform takes a particular shape. John then runs to the west side with Susan, and the landform takes another shape. Meanwhile, the kids lying on the grass are ecstatic that John and Susan are changing the landform rapidly. Susan and John then walk to the east side, and another shape occurs. Finally, John and Susan cross the street and see the landform slowly moving up and down again. The morphing ground consists of a flexible surface that is triggered by the inputs of two IR proximity sensors and is actuated by 3 motors. 3 LEDs are incorporated to captivate onlookers and convey information about the surface. In essence, the ground can perform 4 movements based on sensor data. However, the motors are programmed to move from the positions from which they last stopped. This means that the time of sensor activation impacts how much the motors move in each motion scenario. John and Susan's experience was brought to life by the interaction of people within the environment. Initially, when people have not triggered the sensors, 2 motors move inversely. The back motor moves from 90 to 0 degrees to allow for upward actuation, while the middle motor moves from 140 to 50 degrees to allow for downward actuation. During this movement, the 3 LEDs alternate blinking on and off. When only the left sensor is triggered, the middle motor rotates from the angle at which it stopped up to 140 degrees, thereby moving the middle of the surface upward. While this movement is occurring, the blue LED is on. When only the right sensor is triggered, the back motor rotates from the angle at which it last stopped up to 90 degrees, thereby moving the back part of the surface upward. The white LED blinks during this movement. When both sensors are triggered, the back motor moves from its current position to 90 degrees for an upward actuation. Then the middle motor moves from its current position down to 50 degrees to allow for an upward actuation, while the back motor decrements from its 90-degree position to give a downward actuation. The 3 LEDs blink on and off at the same time during this movement. Lastly, the side motor proceeds to pull the front of the surface to the left and then releases the surface to the right, creating another dimension in which the surface can move. The red LED blinks during this movement. Through further research, the morphing ground concept was incrementally expanded to a fun, interactive, sensory-driven, playground-like environment that serves as an urban landscape.